Minnesota DNR here at our office since 2003, basically working with trout and salmon. So my job, as Nadine stated, a lot of it, her presentation just focused on the steelhead. It's a strain of rainbow trout. As you guys look on the internet or picture what a rainbow trout looks like, it typically looks more like this. This is the Kamloops strain of rainbow trout. These are the two strains of rainbow trout that we manage for in Lake Superior. The steelhead strain is more of the fly fishing purist angler sought fish that the guys with their fly rods are out pursuing, and it's a catch and release regulation, as Nadine stated. But as managers, we manage for the fly fishing purists, which like to go out and just enjoy it for the sport and catch and release fish, and we also manage for individuals that like to eat something. So in the mid-70s, we established this Kamloops strain of rainbow trout, which is a hatchery product. The steelhead strain is pretty much self-sustaining at this point in time. So we do very little stocking with that. But with the Kamloops strain, all their adipose fins are clipped where you can see the adipose fin here is present. So we rear them for a year in the French River hatchery and then release them just in the Duluth area streams, because that's where most of our angling pressure is focused for the spring run of rainbow trout on Lake Superior. So that allows anglers the opportunity to take a fish home if they select to. The other species I deal with are brown trout, which are native to Germany, but have again become naturalized and have been here a long time. The brook trout, which is one of our two native trout species. Lake trout is the other native trout species, which is not up here, but I'm kind of the stream guy, and lake trout are lake-dwelling fish. And then the three species of salmon that we brought in the early 70s are the pink salmon, the Chinook salmon, and the coho salmon. Some refer to the Chinook as kings also. So basically my job is to understand everything that's going on with these fish populations, whether it's a general abundance or age structure or size structure or their genetics or disease issues. Basically what's happening with all their populations and how they're affecting everybody else and what's affecting them. All right, so Nadine talked to me a couple weeks ago and asked me what I would present, and a couple ideas came to my mind. I'm a judge for the Northeast Regional Science Fair here at UMD, which some of you guys probably send your students to. So scientific method was in the title that I gave her, and that's an important concept to grasp. And it doesn't matter whether you're assessing what cell phone people like using or some question on fish on Lake Superior, as long as the students grasp the concept and the method, that's a very important thing for them to go on in the rest of their life. And I talked to Nadine, and I'm throwing her a curveball a little bit with this presentation, which you might have noticed, because the things that I'm currently working on are some steelhead and brook trout genetics studies, which are very interesting to me. But then last Thursday and Friday, I was going through my presentation, which I prepared, which I'm not giving today, and I kind of imagined staying up here and saying, well, you guys might find them interesting, but your students probably won't get much from learning about genetics of steelhead in Lake Superior or something like that. So this is a recycled talk that I gave in 2006. St. Paul basically asked in 2006, when they started getting a lot of money for what they call aquatic management areas, and they're basically riparian areas along streams that we get funding through the state legislature, and we buy angler easements or we outright buy the property. And we basically had to sell the northeast portion of Minnesota to the people in St. Paul and convince them that they should send some money our way. There aren't a lot of people up here, and if you've driven between here and Grand Marais, a lot of it's already natural. So there aren't the impacts that you might suspect up here that you can visually see in southeast Minnesota streams. So lots of money gets sent from St. Paul their direction, and we had to make a ploy for money getting sent our direction. So I looked through this talk, and I thought it had a lot of things that you guys could draw from when teaching in your class, and hopefully you get ideas on what the environment is up here, and lessons you can go go through for your kids. So the presentation outline, I'll discuss the environmental conditions that are present on our Minnesota shore of Lake Superior, and that's what I'll basically refer to as the region between here and Canada, all the tributaries that flow into the lake, and how these conditions influence juvenile steelhead and juvenile brook trout and trout and salmon in general. And based on this were my recommendations on why I think they should send money our way, and why we should protect areas that might appear in a fairly good state right now, but they still need protecting. So this is a typical northeast Minnesota trout stream, and as Nadine just went through their life cycle, adult steelhead swim upstream and they'll spawn in a very riffly area, which typically is smaller substrates, as you can see over there, not larger stuff, but in the spring the water will be higher and this kind of stuff will be submerged. So the adults will spawn in substrates like that, and then the juveniles spend the first year of their life in a riffle environment, which would basically be described as this. The water here is maybe 6 inches deep to a foot. And then they transition from that riffle habitat into pool habitat. And you'll notice with most streams in Minnesota, I look at this picture and it's a really hard thing to find a pool. And by a pool, I mean something that's 2 to 3 feet deep. And they need that water depth and that habitat to basically spend the winter in, and to spend their time in when the water is low, when the water gets warm in the summer, and during the winter conditions. So a limitation of our streams in northeast Minnesota is we don't have a lot of this pool type habitat. So any sections of stream which are deeper and have more overwintering or oversummering or deeper pool habitat are very important to protect. So our very brief geology lesson, I'm not a geologist in any way, shape, or form, but there's another photo of our streams, and you look at that, and that's what our streams look like in the summer. And it doesn't really look like much of a stream if you're used to, you know, what you imagine a stream or a river looking like in your head. It just looks like a boulder field. Our watersheds are set up where we've got bedrock in northeastern Minnesota. So you dig down 6 feet in your backyard, which the top 6 feet will be clay. That's our main primary soil. You get down and there's bedrock. So our streams are very flashy because the substrate, the soil substrate, clay, and the bedrock is very impervious. So whenever it rains, our streams fill up in a hurry. If you looked at many of the streams in the Duluth area when it rains. So this is the Knife River. If you've been on the expressway between Duluth and Two Harbors and you stopped on the bridge and you looked upstream, this is what you see. During the summer, the water is very low and clear, and as soon as it rains, this was a 2-inch rain event, which it took it from this condition to this condition. And you can see it goes from cubic feet per second of about 15 to 20 CFS to this is about 1,000 CFS. So orders of magnitude higher, just because our watershed is not impervious. So again, when you're focusing on where to conserve land or spend your angler dollars buying property, anything with wetland is very important. You'll also notice that the streams go from clear to turbid as soon as it rains, and in our upper watersheds we have clay. That's a primary substrate, soil substrate in northeastern Minnesota, which is not the best thing in the world. Basically, clay, whenever it rains, when the fish are spawning, clay can bind to their eggs and basically suffocate the eggs, kill the eggs. And all the macroinvertebrates that live in our streams, which are secondary production, primary production would be algae, periphyte, and those types of things. We don't have many plants. But secondary production, your macroinvertebrates that the trout would eat. Also, most of them have filamentous gills like a fish, and the clay binds and suffocates those also. So protection of areas that have sloughing banks, or purchasing those areas and modifying them so that's not a big source of input is an important thing.